All right, let's dive right into a really fascinating concept from Thomas Kuhn's The Structure of Scientific Revolutions. We're going to talk about this idea that most science, day in and day out, isn't really about those mind-blowing breakthroughs. It's actually a lot more like solving a puzzle.
We have this image of scientists having these sudden eureka moments, completely changing everything we thought we knew. But is that what the daily grind of science really looks like? Well, Thomas Kuhn said, for the most part, not at all. It's something very different.
In fact, and this is kind of surprising, the source material points out that for the vast majority of research, the result is pretty much anticipated before the work even starts. The goal isn't to find something totally new and unexpected, but really to make the existing theory and what we see in nature line up just a little bit better.
And this right here is what Kuhn famously called normal science. It's all about research that's built on a solid foundation of what came before. He also called this foundation a paradigm. You can just think of it as the shared rulebook for a specific scientific field. It's got all the accepted theories, the right methods, and the standards everyone agrees to work with. So let's think about this. If you're a scientist working inside this paradigm, your job isn't to go around questioning the basic rules. Nope. Your job is to build on top of them. It's to solve the little problems that the paradigm itself tells you should be solvable. And this is where the pressure really builds. If your experiment doesn't give you the result you were expecting, the first thought isn't, oh, maybe the whole theory is wrong. The first thought is that you messed up. The researcher gets the blame, not the paradigm. It stays completely unquestioned.
Okay, so this whole perspective leads us straight to Kuhn's big metaphor for what normal science is really all about. It's not like you're some explorer wandering through a dark, unknown jungle. It's way, way more structured than that.
Kuhn basically says that scientists are really driven by the challenge of the puzzle itself. The real kick, the excitement, comes from knowing that a solution definitely exists and believing that you've got the smarts and the skill to be the one who finally finds it.
And this chart really nails the distinction. In Kuhn's world, normal science is about puzzles, not what we might call grand problems. A huge problem like, say, curing cancer might not even have a solution with the science we have today, but a puzzle? A puzzle is defined by the absolute guarantee that a solution is there waiting. So the focus shifts from how important the answer is to the skill and the elegance of how you get there.
So that brings us to the next point, doesn't it? Every good puzzle, every game, needs a clear set of rules. You have to know what it means to actually win. The jigsaw puzzle is the perfect way to think about this. When you open the box, you know a complete picture is possible. And there are these unspoken but absolute rules, right? You got to use every single piece. You can't just jam a piece where it doesn't belong. And at the end, there can't be any holes. Just making a cool shape with the pieces doesn't count. You haven't solved it. A scientific paradigm does exactly the same thing. It lays out the rules of the game, all the concepts, the lab techniques, the theories, and here's the crucial part. It also handpicks the problems that are worth working on because it gives the community total confidence that those problems can be solved.
And of course, there's a flip side to this. Any problem that you can't state using the language and the tools of the current paradigm, well, it often just gets dismissed, shoved aside. It gets called metaphysics or philosophy or just a plain waste of time. The paradigm basically acts like a filter, focusing all that brain power on a very narrow, specific set of puzzles.
So this begs a pretty big question. If you basically know what the result is going to be, and the rules are super strict, where's the fun? What actually keeps a scientist motivated in coming into the lab every day?
Well, according to Kuhn, the motivation is deeply, deeply personal. It's that competitive fire, that drive to be the person who finally cracks the code. It's all about proving your own cleverness by solving a puzzle that nobody else has been able to solve before you. You know, the scientists doing this kind of fundamental work, they're usually not thinking about building a better bridge or a more efficient car engine. That stuff might happen later, sure, but the real driver, the thing that gets them going, is the thrill of the intellectual chase. It's the pure satisfaction of making all the pieces click into place perfectly.
Okay, so picture this. You have this whole community of brilliant people, and they're all laser focused on a tiny set of problems that are all defined by one single paradigm. Well, this structure, as it turns out, is the secret to science's incredible power.
One of the biggest reasons science seems to move forward so incredibly fast is precisely because of this. The pros are concentrating only on problems that the paradigm pretty much guarantees can be solved. They're not spinning their wheels on questions that their current tools just can't answer. This intense collective focus lets the scientific community dig so much deeper into one little corner of nature than they ever could otherwise. They flesh out the paradigm, they stretch its reach, and they fine-tune their measurements with an absolutely incredible level of precision. This is the engine that drives detailed, step-by-step scientific progress.
So this model of normal science as puzzle solving, it's unbelievably productive. It explains that steady, methodical progress we see almost all the time. But it also leaves us with this really provocative question at the end. What happens when a piece just won't fit, no matter how clever the scientist is? Well, that is when things start to get revolutionary.